Welcome back, ladies and gentlemen. Now we're dealing with section 8.5, day 4 of solving equations. We're going to be solving equations involving radicals, rational exponents, and absolute value. Okay, now I put the homework on this slide just for space concerns, so don't freak out. Alright, here we go. Solving radical equations. Okay, now the big thing, radicals of course are just any type of root. In this case we've got a square root. Okay, now best idea to get rid of a square root is to square stuff, but you do need to be careful that you isolate that square root first before you square both sides. Otherwise, don't write this down. But if I tried squaring both sides right now, I have this really nasty FOIL sort of thing that has a square root involved with it, and you just don't want to do that. So the very first thing you want to do is actually add 5 to both sides in this case, leaving us with root x plus 9, giving us 11. Now that the radical's by itself, here's a perfect time to square both sides and not create a nasty FOIL situation for ourselves. So that'll leave us, of course, with x plus 9 equals a 121, and simply subtracting 9 from both sides now will give us a 112. Okay, of course, what we do have to watch out for when we square both sides is maybe introducing extraneous solutions. So plugging the 112 back here into the original equation to check it out is very necessary in this case. Although one of the big red flags will be if this value creates a negative number under the square root, then that's obviously going to be a bad thing. This 112 does check out. I won't waste the time right now showing, but it's a good solution. Alright, let's take a look at a little nastier version of the problem. Okay, now what's nicer about this one is actually the radical is by itself, but in this case I have a fifth root instead of a square root. But the same basic concept applies. Whatever the root I have, I need to use that power to cancel out the root. And so in this case, just to show the work, I'll throw a fifth root over there. Of course I need to throw a fifth root on it too as well. Alright. Okay, the radical side is actually, believe it or not, the easier side, because all you have to do is let the radical and the exponent cancel each other out, leaving you with whatever's underneath the square root, or in this case the fifth root actually. Alright, and then here I've got 2 to the fifth, and well of course 2 to the fifth is 32. Okay, now what we've done is created a nicer looking equation out of a very nasty looking one, I suppose. And so now at this point, well, it's quadratic, so I'm thinking maybe I can factor this guy. So I'm going to pull the 32 over to the left hand side. If you're a fan of completing the square, this guy's in a nice position to complete the square, and you could have done that. But whatever the case, okay, I'm going to break my 32 into a 2 and a 16, and that will allow me to get this guy factored very nicely with a minus 16 and a plus 2. So I have two answers. I have negative 2 and I have positive 16. Again, though, we need to be aware of if we plug things in, whether or not we get extraneous solutions. Okay, now, again, just to save time, I'm going to let you know that these two both actually are valid solutions, but it is definitely worth your time to plug them in to check them out. Alright, moving on to equations with rational exponents. Well, rational, of course, just means fractional, so that's what we have here. I've got an exponent that's a fraction. Alright, well, the same basic thing still applies. I want to cancel things out. And, well, what I'm going to do is I'm going to raise the left side to a power that will cancel out the exponent that we have. Well, okay, if I raise a power to a power, the rule is that I multiply the exponents. So if I take the 4/3 power and raise it to the 3/4 power, multiplying reciprocals of each other will just cancel each other out, effectively giving us a 1. So that's what I'm going to do. Although we do have to be super careful here, because remember, if I'm talking about a rational exponent, the bottom number is basically the root that you're doing. The 3 is the exponent, but the 4 is the root, and that's the most important, because the root, if it's an even root that you're doing, you're going to need to watch out for a plus or minus. Okay, so if this was the 4/3 power, an odd root, well, I don't need the plus or minus, but for an even root I do, so be very cautious about that. Okay, with all that babbling aside, the left side again looks the messiest, but works out to be the easiest because these guys just kill each other off, and we're left with the x plus 6 sitting there by himself. Okay, the 81's a little bit trickier, but remember, I've got that 81, and if I've got the 3/4 power, okay, again, the 4th is the root, so this is really the 4th root of 81, and then the 3 is an exponent, so it's being raised to the 3rd power. 4th root of 81 is 3, and then 3 to the 3rd is going to be 27. So really I end up with a 27 over here, but remember, since I did an even root, I need plus or minus 27. Okay, now that's very easy to forget in this situation, so you do have to be careful here. Okay, at this point, subtracting the 6 off of both sides, you get negative 6 plus or minus 27. And then since these are like terms, I would want you to work that out and give me two solid answers. So the negative 6 plus 27 gives me a 21, and then the negative 6 minus 27 gives us a negative 33. Okay, again, we are in a situation where it is important to check for extraneous solutions, but again, these two both work out just fine, so we get to keep them both because they're just so lovely. Alright, now this one, yes, looks pretty nasty, although there's some very important calculus skills involved in this one, so that's why I feel it's very, very important to cover it. Alright, well, first thing first, looks just rough right off the bat, but if we look at this x minus 2 to the 1/4 and the x minus 2 to the 5/4, there actually is a very important connection between those two. Other than the x minus 2, the exponents play together very, very well as well. I'm going to do something you may not have to do yourself, but just to illustrate what's happening here, I have my 7x, x minus 2 to the 1/4. I'm not changing that at all. What I am going to change is this guy. Okay, if I've got the 5/4 power, that's like having 1 and 1/4. Okay, now, again, I'm not usually a fan of mixed numbers, but I think this helps illustrate things very nicely. So really, I have an x minus 2 to the first power smashed up against an x minus 2 to the 1/4 power. Again, 1 and 1/4. So I have this guy to the first, which I normally wouldn't bother to write, but pairing it up with the x minus 2 to the 1/4, again, that's 1 and 1/4, the 5/4, equals 0. Okay, what that does for us now is creates a kind of a greatest common factor between the left half of the left half and the right half of the left half. So this guy right here is a common factor that I can actually pull out. Alright, so that leaves me an x minus 2 to the 1/4 power. Okay, what we just did is the important calculus-y sort of thing that you need to be able to do. Alright, so that being said, I'm going to use a bracket here because there's a lot of other mess going on, and I want to make sure I can separate what's going on. But here we go. I've got a 7x plus, and again, what I didn't just pull out is just the 6 and the x minus 2. Again, I'm going to drop the 1 on the exponent there. Okay, now in this bracket, I can clean this up a little bit with a little bit of distribution. So I've got x minus 2 to the 1/4, and then this, if you'll permit me to do so, this is really 6x minus 12. So 7x plus 6x gives me a 13x minus the 12 equals 0. Okay, and now what I'm looking at is two different things, two different factors, if you will, to make 0. So of course I can split those into two separate equations. So I've got an x minus 2 to the 1/4 equals 0, and then I've got my 13x minus 12 equals 0. Okay, at this point I can do the 4th power to both sides of the left equation, leaving me with x minus 2 equals 0, so I get a pretty clean x equals 2. Over on the right side here, I've got 13x equals 12, and then x equals 12/13. Now there's a kind of icky thing that happened. Alright, well this 2, if you think about extraneous solutions and plugging things back in, I can plug in a 2, and this whole quantity becomes a 0, which basically takes out the whole left term, and then this also becomes a 0, which takes out the whole right term, and basically I'm left with 0 plus 0 equals 0, so that works just fine. The 12/13, I'm not going to do all the work here, but if I plug in 12/13, which is a number slightly less than 1, and I take that number slightly less than 1 and subtract 2, I clearly get a negative answer. Well, remember the 4th root, or the 1/4 power, is basically a 4th root, and I can't take an even root of a negative number. So by plugging in this value into this quantity, I generate a negative number which I can't take a 4th root of, so that solution becomes extraneous. And all I have as a final answer is the 2. Let's cross him out just to make sure, stress the point he's gone. Alright, now moving on to absolute value equations. Okay, now, I've been solving these for a little while now. I think the first time they crop up is in Algebra 1. Alright, so we've got a 5x minus 7 equals 22, absolute value. And again, absolute value just means you're making something positive. So the guts in here could equal 22 to give me 22 as the absolute value, or the guts in here could equal negative 22 to generate an absolute value of positive 22 again. So that's the thought process there. The guts, if you will, 5x minus 7, could be the positive version of this number over here, or the guts inside could equal the negative version of this number here. Alright, because of course if this was negative 22 and I took the absolute value of it, I'd get positive 22. So basically this absolute value is always going to spawn two separate equations to solve. Alright, my left side one, adding 7 to both sides gives me a 29, and I divide through and get 29/5. Not the prettiest number you've ever seen, but there it is. Okay, over here on the right, adding 7 to both sides now gives me something a little nicer, a -15, and then dividing through by the 5 gives me an x equals 3. Alright, so just to consolidate it, make it look all pretty, I've got 29/5, and I've got 3. Okay, the good news with the absolute value equations with no other bells and whistles, there's not much of a need to check for extraneous solutions. I mean, it's worth your time to check it just to make sure you have the right answer, but in general, without any other fanciness, you won't generate extraneous solutions. Alrighty, but of course the situation can get a little bit nastier, and here we go. Okay, but again, same concept applies for the simple problems as for the complicated ones. Alright, so I've got my guts, if you will, can equal the thing. In this case we still have a variable involved with it, but it's no different. Okay, I've got one possibility of the guts equaling the positive version of whatever this thing is. Okay. Or the guts could equal the opposite of what's sitting over here. And the opposite of positive 5x plus 6 would be negative 5x minus 6. Okay, so now what we've done is generated two quadratic equations to solve, and then just use whatever normally you would do to solve a quadratic equation. Okay, I'm a big fan of factoring if it works, and if factoring fails, then I just use the quadratic formula usually. But here we go. So x squared, I'll bring the 5x over as a minus 5x. Okay, then I bring the 6 over to the 30, and I get a negative 36 equaling 0. And that guy looks like he factors pretty nicely, so that's going to give me an x plus 4 and an x minus 9 as my factors. So that gives me solutions of negative 4 and 9. Okay, moving to the other one. Again, same thing, I'm just smash everybody on the left. So now I have a positive 5x, and adding 6 to both sides here gives me a negative 24 equal to 0. And conveniently, this guy also factors into an x minus 3 and an x plus 8. Okay, and I get two more solutions here. I get a positive 3 and I get a negative 8. Okay, now the bad news is extraneous solutions might crop up here because, again, I've got some extra bells and whistles and variables on the other side as well, so we have to be a little bit careful about things. Okay, well, plugging in a negative 4, for instance, if I plug in a negative 4 over here, I get negative 20 plus 6, which ends up being a negative 14. Okay, well, an absolute value can never equal a negative result, so unfortunately he's got to get thrown out. Okay, now the 9 does work if we plug it in. Again, I'm not going to do all the work. That does work, please trust me. Or if you don't trust me, work it out yourself, feel free. Okay, so as part of my final answer here, I'm going to include the 9 and maybe somebody from this side. Okay, now, based on what I just did, you might realize that now the 3 I can plug in and it works just fine. But if I try plugging in that negative 8, again, I get a negative number over here that's much bigger than the 6, so I end up with a negative side, which can't be the result of an absolute value, so the negative 8 gets thrown out as well. Please do not assume that just because you see a negative answer, you automatically throw it out. That is definitely not the case. It just happened to be that way for this problem. Alrighty, anyway, just test them each and every one of them, and you got nothing to worry about. Alright, any questions, of course, ask me in class as usual. I'll see you then.